Hi everyone. Today we will talk about how to apply TensorFlow and neural networks for handwritten text transcription. So the problem we are facing right now is that what we learn in class is applied in local virtual machine. It's good for experiment, but not for production in real life. Also, we are using mainly the dataset MNIST, the number database, which is very small, very nice, and good for testing, but not realistic for big data. And thirdly, what we have learned up now is the low-level TensorFlow API, which is very versatile. You can create very complicated models, but it's a little bit time-consuming to use. You have to manage the session, the graphs, and have to make sure that variables is initialized. All these kind of things would add to the researcher's head and drag down the speed of the modeling process. So with these three problems, we try to learn something new that can overcome these challenges and make the machine learning efforts easier and faster. So our goals are follows. Firstly, we try to set up an AWS cloud server for machine learning efforts. Secondly, we try to process a relatively large data set, which is not just 1 or 2 megabytes, but several gigabytes. Thirdly, we will introduce some high-level TensorFlow API, specifically the dataset and estimators. Now, let's go to some technology description. Firstly, what we are going to use is the AWS Deep Learning AMI. As said in the official website of AWS, Amazon, we can get started using TensorFlow AWS by simply launching the image of deep learning, which is already prepared by Amazon. It has pre-installed TensorFlow, Python 2, 3, Caffe 2, Torch, Keras, all kinds of toolkits that you may find valuable for your machine learning efforts. Secondly, is about TensorFlow datasets. The dataset API different from the traditional queue-based input API in TensorFlow. It makes it very easy to deal with large amounts of data in less amount of codes. And it can handle various data formats, including string, bytes, numbers, graphs, many things. And it's very easy to use. And you can also pre-process the datasets, use some mapping and shuffling and also perturbation. So it's also very versatile. Thirdly, we will introduce TensorFlow Estimator. The estimator is a wrapper. It helps you get away with the sessions, the graphs, but focus on the model learning parts. Okay, then we are going to discuss the data we are using. We're using the NIST Special Database 19, which is handprinted forms and characters from over 3,000 writers. It provides about 800,000 isolated character images, like the case shown in the PowerPoint. It has digits, uppercase, lowercase, in English letters. So it actually provides about 62 labels that we need to classify. And the size about 6 gigabytes, which is much larger than we expect. In the before the data in minutes is 28 times 28 pictures, but here the size of pictures is 128 times 128. That's why the size is bigger. Okay, So with these three facets, we are going to first set up the AWS. So, as we see, what we're going to do is to install nothing, but to launch an EC2, Elastic Computational Resourcing on AWS. You need to sign in to AWS console, and then you can search EC2 and choose launch instance. After several process, we won't go through the detail. It's available online. The thing is, you cannot have only 30 gigabytes of size. It requires you at least 50 gigabytes to start. And once you start doing machine learning, you realize you need much larger data storage than 50 gigabytes. You probably need 100 gigabytes. That's why I choose, but here we are showing 30 gigabytes to show you that's not what we use in real life. We need to use a much larger data storage. And another thing we need to take care of is that if this is your first time to launch an instance, then you need to ask for a limit increase for some specific instance. For example, now we are here launching the P2X large, which is a GPU-based instance in deep learning. And to use that, we have to write an email in the request page as shown here to increase the limit. And also make sure the limit is increased in the right region that you are going to launch your instance. After that, we can start launching our instance. As we see here, we launch our instance in Northern Virginia and it's running perfectly. So after we launch an instance, we will SSH into the server using the PAM key. And the first thing we need to do is to install the package of img.io. Img.io is used for reading the data of PNG file and convert it into double array. So we need to activate the virtual environment and then install it as we shown here. After installing it, we can try to launch a Jupyter notebook. We need to SSH specifically here to open the localhost address. The bear here is the nickname I give to my machine, and which you need to configure through the .ssh config. And then in the server, when you type Jupyter Notebook, it will show you a token with the address. Then you just copy paste, and you can launch the Jupyter Notebook. And this is the Jupyter Notebook that we could see. With the notebook in your local IDE, you can start writing code, testing code, and training your model. Okay. After that, we will show you some brief introduction of the dataset. So here, we borrow some code from the TensorFlow official website and adapt it to our own needs. This is a decoding function to decode the raw image into a flat array of features and labels and return it in a dictionary. And then we use a wrapper to wrap the dataset API. It's easy to see that we use a TF record dataset in the file path. We can easily map the content of the dataset to numerical values, because when we store it in a byte serialization string. So we need to decode it. And we can choose to shuffle the data or not. and then we can choose what's the batch and what kind of iteration we use. After that, we can create estimator API. Because we want to have a custom API or custom model, we need to follow the model framework of estimator. We use the framework shown here to configure a model that is not in the predefined estimators. So the procedure is quite simple. We need to configure the model of TensorFlow, which usually for convolutional neural network is the structure of neural network. The convolution layer, pooling layer, dense layer, and finally logistic softmax. And also the second thing we need to define is a loss function for training. The third thing is optimizers. And the fourth is to generate predictions. And the fifth, we could return the estimator specification. Once we define this, we can put it into as a function to tf.estimator.estimator initializer and create an estimator for us. And we save the model in the ./cn underscore model, which is where the graph and checkpoint and evaluation matrices is stored. As we see, we can input the data using custom input function that we just defined with the train file path. We use 5,000 steps to train it. After that, as we see, the neural network is converging quite fast. With 600 steps, it decreases the log of 4 on 4 to 3. After training, at the same time of training, we can see the training process using the tensor board. You just set the log directory to the model directory and you can see the results. Okay, after that, after the model is trained, we can evaluate our result. As we see, to evaluate the result, we only use the object of new classifier .evaluate, and we input the input function with the testing file path. Then we can estimate. The result of the evaluation is shown in the picture. It's 47.7% accuracy with a loss of 1.82 for this 1000 evaluation sample. It's quite amazing because we only train about 5,000 steps, and the convolutional neural network is not fine-tuned for this specific purpose. So it's quite good. And we can visualize our predictions using the first 4 testing file. As we see, luckily we get all 4 characters, no, 3 out of the 4 characters right. The first one is U to U, R to R, A to A. The last one is M, but we predict M. But it's quite reasonable because this one is not very well written, and even human may not recognize it. So, and finally, to wrap up, the key lesson learned is that when we trying to deal with a problem, it's important to have a scope. Otherwise, it's easy to get lost with all the technical details. And with every emerging technology, there are so many details you need to go over to make the implementation succeed. It's very useful to have a big picture in mind to time yourself. Secondly, we should be careful of what API we use. For example, in TensorFlow, they update their API quite frequently. So we need to find the stable API that they are more likely to take care of and develop well. Thirdly, we need to be careful of implementing the model with the mind that we will need to deal with a lot of technical details. and the documentation may not show everything. So be prepared to use Google a lot, Stack Overflow a lot. That's our good friends. Fourthly, for general purpose, it's always a good idea to start testing with small data sets, even we're dealing with big data. For here is a 6 GB data set. It's good that we start using it with maybe a subset of it, maybe a 0.01% of the data. And that will help us to get our code work and work well much faster. So that's all for our presentation. Thank you very much.